Hello Year 10 and welcome to a new topic on straight line graphs. And today we're going to start off by doing a little review of coordinates, and then we're going to look at finding the midpoint of a line or a pair of coordinates. So coordinates will be very familiar to you, but it's always worth having a review because there's a lot of room for confusion. You have a pair of coordinates given to you in brackets with a comma in between the two. The first number in your bracket is the x coordinate, and this is the x-axis right here. And then the second number in your bracket is the y coordinate, which tells you where we are on the y-axis just here. This bit right here where there's a circle, this is the coordinate 0, 0, and sometimes that gets called the origin. Okay, so our grid has two axes, the x-axis and the y-axis. Right, so we're just going to remind ourselves how to plot coordinates. So we've got here the coordinate 2, 3. Remember, x comes first, so we're going to 2 on the x-axis and then 3 on the y-axis. And so 2 along, 3 up, and we end up plotting our point on the grid line nice and neatly, just like that. Now, our coordinate grid here has 4 quadrants. This is the positive quadrant because x and y are positive, but we can get some negative values as well, like this. So in this pair of coordinates here, we've got x is 4, which is right over here, and then we've got y is -2. So we're going to have to go down to -2 on the y-axis. So 4 along and -2 up, or 2 down, and that's where our coordinate is sitting right here. Okay, so now what I want you to do is, in your books, pause the video and write down the coordinates of these 4 points, A, B, C, and D, in your book. Okay, so you should have got the following answers. So A is the coordinate 3, 4. B is the coordinate 1, -2. C is -5, -3. And D is -3, 2. So we've got one coordinate in all 4 quadrants. Now next, you're going to be asked to plot some coordinates. Now I'm not going to expect you for the moment to draw this grid into your books. If you can just sort of put your finger exactly where on the grid, on the screen, you think this coordinate should be plotted. I'll pause for a second just to give you a bit of time to think, and then I'll tell you whether you're right or not. So first of all, the coordinate E, 4, 1. Okay, so your finger should be sitting right where that cross is there. E, the coordinate 4, 1, 4 along the x-axis, 1 up the y-axis. Next, F, 0, 4. Okay, a bit trickier this one because we've got x is 0, so here is where x is 0. So this point is going to be sitting actually on the y-axis where y is 4. So your finger should be right where that cross is, that has an F mark next to it. Next one, G, -2, -1. Okay, your finger should be sitting right here where the G is, or where the cross is. And finally, H, 4, -4. Put your finger on the screen where you think that should be plotted. Okay, and you should have your finger right here on the cross next to the H. All right, so here are some more problem-solving coordinates questions. Question 1A, you've got to think about where you could plot a point to make this shape a square, so to finish off the shape and make it a square. B, you've got to do something very similar. You need to work out where you would plot a point so that you make the shape into a trapezium, and there could be more than one right answer here. And then right here you need to think about, if A and B stay where they are, where could you move C so that you still have an isosceles triangle? And then finally, where could you move C so that you had a triangle that was both isosceles and right angled? And again, there could be more than one answer there. So could you pause the video? You don't necessarily need to draw this out into your books either. You can just have a think about where it would be on the screen and then make a note of the coordinate into your maths book. So pause the video and see if you can answer the questions. Okay, so let's go through these then. So 1A, where would you put point B so that you had a square? And that needs to be right here at the point 5, 2. There's only one option here, and people often forget that a square is still a square even when it's tilted onto its side. That is not a rhombus, it is not a diamond, it is still a square. Right, where would you put point E so that you had a trapezium? So you need to remember, for a trapezium you need a pair of parallel sides. So two options here. One is if you create a side that's parallel to AB, in which case it needs to be sitting somewhere along here. And one is you create a side that's parallel to BC, in which case it needs to be sitting somewhere along here. So there's an example of where you could have put your point, but it might just as well have sat down here. Couldn't have been there because we'd have had a square, but it could be down here, could even be here. Okay, the alternative then is that the trapezium is that way round, and so you had a point over here, but again, it could have been down here at this point, it could have been up here at this point, so lots of answers you could have had there. Right, question 2, where can you move C so that you still have an isosceles triangle? Well, actually, if you move it anywhere along this line right here, which is the line x equals 6, because the x coordinate anywhere here is 6, you will still have an isosceles triangle. The only exception is if you plot it right there on that line between A and B, because then all you'll have is a straight line. So any point with the coordinate x equal to 6. And then where could you have moved C2 so that it was isosceles and right-angled? Again, lots of options. I could have put C, it needs to have a side length of 4, so it could have been right here at 4, 5. Or it could have been over this side, or it could have been at the point 6, 3 right here, because then our angle here at the top would have been a right angle. Okay, so we're now going to move on to something that is almost certainly new for you, and that's about finding the midpoint of two coordinates, or you could be given a line and asked to find the midpoint. So in this example, we've been given the two coordinates 1, 2 and 5, 4. And what I want to do is find where the point is sitting that is halfway between the two along the line that I could create if I joined them up. Now, you can actually do this by eye. So you can probably see already that this right here is going to be sitting in the middle. And if you're given a question where you can do it by eye, that's fine. But typically you won't be. So we need a better strategy. And so what I'm going to do is look at how far along I'm going between one point and the other. And to find that, I've got to do this x coordinate here, subtract this x coordinate over here. And that tells me that I'm going along 4 along the x-axis between the 2 points. And then if I want to find the midpoint, well, I must need to go halfway along that distance along the x-axis. So halfway along is going to be 4 here divided by 2, and that's going to be 2. So I'm going to go 2 along to find the midpoint, and now I need to work out how many I'm going to go up. So to find that, I'm going to look at the difference between the two y coordinates here. How far have I gone up from 2 to 4? And to do that, I'm going to do 4 take away 2, which is 2. And then to find the midpoint, I'm going to need to go half that distance. So I'm going to need to half 2 and 1. So from here, I'm going to need to go 2 along and 1 up. That won't tell me the coordinate though. The coordinate is not 2, 1. We can see it's 3, 3. So how do I find out the coordinate? Well, I went 2 along from where I started, which was where the x coordinate was 1. So 1 plus 2 is 3. I started at 1, I went along 2, and I ended up at 3. And the same for the y coordinate. I started at 2, so I started here, and I went up half the distance between the two, so I went up 1, and that meant I ended up at 3. So my coordinate is 3, 3, which is right there in between the two. Okay, so what happens if I generalise that a bit? I don't know what the coordinates are now. I've just called them x1, y1, x2, y2. So I'm now going to think about what I did on that last question when I had numbers, and I'm going to generalise it. I looked at the difference between the two x coordinates. I did this one, the second one, subtract the first one, which is what I've got down here. And then I wanted half that distance. So I halved it. x2 minus x1 divided by 2. Now going up between the two as well, I looked at the difference between the y coordinates, y2 minus y1, and I wanted to go half that distance. So I halved it, y2 minus y1 divided by 2. And then what I had to do was add those two different amounts of x and y to where I started. So I did x1 plus this distance, which is what I've got written over here. And then I did y1 plus this distance, which is what I've written down over here. And actually what we can see here is we've got a whole x1 subtract half of an x1. And we've got a whole y1 subtract half of a y1. So that means I'm going to be left with half of x1 and half of y1. And I've got half of x2, I've got half of y2. So this simplifies to give me this formula for finding the midpoint. And this is something that you're going to need to learn. But if you just remember that you add the two x coordinates and halve them, and you add the two y coordinates and halve them, that will always give you the midpoint. So what you need to do is pause the video. You're never going to need to reproduce how that formula is found, but you should have a rough idea of where it came from. All you need in your book is this formula. That is what you're going to need to use. So pause the video and make a note, and then we're going to look at a couple of examples. Okay, so find the midpoint of the two coordinates 3, 5 and 6, 9. So I'm going to add my two x coordinates 3 and 6 and halve them, add my two y coordinates 5 and 9 and halve them. 3 plus 6 is 9, 5 plus 9 is 14. Now I've got to halve them, and that gives me 4.5 and 7. And that's my midpoint. Next question is trickier because I've got some negatives creeping in here, but it's still the same process. I've just got to remember my negative number rules. So take my two x coordinates, minus 2 and 7, add them and halve them. Take my two y coordinates, 11 and minus 3, add them and halve them. So minus 2 add 7 is going to give me 5, and 11 add minus 3 is going to give me 8. And now I've just got to halve them to finish off, and I get 2.5 and 4. Okay, so your task for today is to pause the video. Here are a selection of coordinates, and you need to find the midpoint between them just by adding your x coordinates, halving, adding your y coordinates and halving, and then giving your answer as a coordinate. Ignore these blue bits, that's just where I've done a screenshot of a Word document and it didn't like the way these were presented. And we will mark these next lesson. So pause the video, showing full working in your maths book. Have a go at these questions.